You're standing on the roof of a control tower at the airport. You see a huge plane coming in for a landing. It's whizzing over your head, but all you hear is the wind whistling. The first sound the plane makes is the scraping of the tires against the asphalt. That's because this giant airplane runs on electricity. It doesn't need to burn tons of fuel. And it doesn't attract the attention of passersby with its noise as it flies over the city. But engineers predict that all-electric airplanes won't appear for another couple of decades. For now, the Dreamliner 787, which can carry 310 passengers and emits no pollution, remains a sweet dream for designers. Let's jump back in time to 140 years ago. In 1883, a French aviation enthusiast made the first ever electric-powered flight. He installed an electric engine on the dirigible. The problem was that the engine weighed as much as a big motorcycle. So, the dirigible couldn't fly long distances and lift many passengers. Okay, back to our time. The problem of heavy engines and batteries remains unsolved. 1 pound of regular airplane fuel contains 60 times more energy than 1 pound of even the most advanced battery. So, we'd have to increase the airplane's tank by 60 times and fill it with batteries. But now, the plane is much heavier and it can barely take off. So we have to remove a lot of necessary things from the plane, like several rows of seats, toilets, and all the drinks and snacks, so the plane loses some weight. And now, shove more batteries into all the empty places. The plane can take off now, but it can't land. The plane is designed to take off with a full tank and land with almost nothing. Otherwise, its landing gear just can't take the load and breaks when it touches the ground. So, if the plane needs to make an emergency landing right after takeoff, it'll have to circle over the airport until it's burned enough fuel. It's allowed to land only when it reaches a certain weight. But in the case of batteries, the weight of the plane doesn't change during the flight. So designers had to find another solution. Let's drive this little single-engine airplane into a hangar and take out the old fuel-burning engine, exhaust system, and fuel tank. Replace them with an electric engine, which is much smaller and lighter. Pack all free spaces with batteries. The weight of the final version of the plane should remain exactly the same as the original plane. So now, it can take off and fly without any problems. But it can only do that for short distances. And that's a huge advantage of electric planes. About half of all flights in the world are under 500 miles. There's a lot of flights over distances like that, from New York to Washington, D.C., or from Detroit to Toronto. It's less than 200 miles. And there are huge passenger planes flying on those flights. They take off, gain altitude, and then immediately land. Using these gas burners at such short distances is like putting a huge freight elevator in a 2-story house. It's not profitable and it doesn't make sense. All the conventional airplanes in the world emit about 1 billion tons of CO2 a year. So we can reduce the amount of damage to the environment by half by using electric planes. Many designers are trying to convert some planes into electric ones. For example, the Cessna 208B E-Caravan. The normally 9-seat passenger plane now uses an electric engine. As of 2020, it's undergoing certification. This means that every bolt and wire on the plane is tested for safety. This process could take years. ES-19 is an all-electric 4-engine airplane. The aluminum hull makes it extremely light. Although the price per unit is about $8.8 million, its maintenance costs are 90% less than regular airplanes. And electric power for the plane itself is 50 to 75% cheaper than standard fuel. It'll be able to cover distances of about 220 miles. It's great for traveling in Europe or between remote islands. And it can use runways no longer than 2,500 feet. Given that these planes are practically silent, airports could be built close to city centers. This would cut travel time almost in half. Eviation Alice has taken another step into the future. This 9-seat plane is made almost entirely of composite materials and powered by 3 engines. The inverted boat shape and V-shaped tail make its aerodynamics perfect. It has the length of a school bus and the wingspan as wide as a basketball court. Its maximum takeoff weight is like 2 SUVs. 60% of that weight is batteries. This gives it the ability to fly distances of about 620 miles. That's more than the distance from New York to Detroit. The best thing about the Eviation Alice is the economy. Flying 9 passengers and 2 crew at top speed will cost about $200 an hour. For conventional planes of the same class, like Cessna and Beechcraft, that number would be about 5 times bigger. The problem of short-range flights can be solved by a network of abandoned airports in the United States. There are about 2,000 of them and 5,000 public airports. Each of them can be equipped with a charging station, just like a gas station. A half hour at a charging station for Alice would be equal to 1 hour of flying in the air. So while passengers are getting off and on and their luggage is being loaded, the plane can build up enough energy to fly. So, small planes are good as an air taxi or private jet, but you need at least 20 Eviation Alice planes to replace a full-fledged Boeing 737 with 180 passengers. The price for one electric bird is $4 million. So that's $80 million versus $100 million for one Boeing. So, the Alice wins again. Zunum Aero tried to build an electric plane that could carry 50 passengers. The company first went for a 12-seat ZA-10 airplane. It was a hybrid powered by the combined work of traditional and electric engines. Engineers relied on evolving batteries and predicted that their plane would be able to travel 1,000 miles. So it could fly from LA to Seattle on a single charge. And it would only have to cost $500,000 more than Alice. The big 50-seat plane should have worked on the same principle. But the company lost funding before they could introduce the finished plane. Maybe we can create an all-electric plane that doesn't have any moving parts at all. It would use ionic wind. MIT engineers created a lightweight model of an airplane with a wingspan of about 16 feet and no engine. There's a metal structure similar to a fence between the wings of the plane. A battery powers this structure with negatively charged electricity of 40,000 volts. There's the same structure in the back of the wing, which was positively charged. When the structure is powered, its front end captures negatively charged electrons from the air, just like a magnet. The electrons then fly toward the positively charged structure at the back. As the ions move, they collide with air molecules millions of times. This creates thrust, just like a regular airplane. And as it moves, it keeps charging the particles in the air and pushing them back. Engineers from MIT did about 10 test flights. Their plane was able to fly almost 200 feet on ion thrust. But their model airplane only weighed 5 pounds, and it flew without a pilot. The lightest manned airplane in the world, the BD-5J, weighs 7 times more, so it should have giant wings to fit this metal structure for ion thrust. And the voltage in that structure would have to be much higher to create enough thrust to let the plane take off. So this technology needs many years to develop and refine before it can be tested on real-scale airplanes. Right now, one of the most reliable and economical electric engine schemes is to work together with traditional propellers or turbines. An airplane can use an electric motor for a quick and quiet takeoff. It'll gain altitude and leave the airspace of a densely populated city. Then, it'll start the main engines, which run on fuel combustion. This will allow the plane to reach high speed and fly a long distance. During this time, the plane's batteries will be charged by the generator powered by the main engine. When it's time to land, the main engines stop and the plane lands completely silently with the electric engine. So, we're gradually moving toward making airplanes fully electric and silent. Then we can locate airports closer to city centers. This will save travel time and reduce the amount of harmful gases emitted into the Earth's atmosphere.